Let's talk about troubleshooting CPUs and RAM. We'll start with CPUs. And a quick review, you want to make sure you know your A+ six-step troubleshooting process. So step 1, identify the problem. You can't do anything until you know what the problem is. Step 2, establish a theory of probable cause. Question the obvious first. Start with the most likely and make a list of possible causes for the problem. Step 3, test the theory to determine cause. If your test fails, go back to step 2 and move on to the next theory. Then step 4, establish a plan of action to resolve the problem and implement the solution. Step 5, verify full system functionality, and if applicable, implement preventive measures. And step 6, document. Document your findings, actions, and outcomes. You should always be documenting. And if done properly, you will achieve victory. So know that 6-step A+ troubleshooting process for the exam. Apply it to CPUs and RAM and everything else. So now that that process is out of the way, let's talk about one of the troubleshooting methodologies that has served me well over the years, and I call it the Big Four. The Big Four. When troubleshooting PCs, I like to use this concept, especially for computers that won't boot or display anything on the screen, but are receiving power to the power supply. So we're thinking beyond power. So power is a big deal, but we're thinking beyond power for the Big Four. And the Big Four includes the motherboard, CPU, RAM, and the GPU, meaning the video card, and not necessarily in that order. But again, none of this will work without power. All right, so here we have a power supply. Now the rule, I'm showing this picture for a reason. The CompTIA A+ rule is this: don't open power supplies. They can hold a lethal charge that can injure humans. So we don't want to open them. If a power supply is considered bad, we send it out to the proper repair center where they have the right facilities and the right safeguards in place to protect their technicians. So for the A+, we don't repair these. We don't open them. We simply test and see if they work or not. And usually we'll do that with a power supply tester like this one. And this is a Dr. Power 2, which has a 24-pin ATX main power connector on this side. And then we have PCI Express, we have 8-pin CPU, we've got Molex or peripheral, and we've got SATA power. And here's some readouts here for 5 volt, 12 volt, 3.3 volt, negative 12 volt, and so on. And I show how to use this exact tester in another video. So that's what you want to do when you're troubleshooting power. You want to check the power supply with a device like this, but never open the power supply. So you got to have power before you can do anything else. Then you can talk about the Big Four. Then we can get back to the CPU. Now here's the thing. The CPU can be a real hassle to uninstall and reinstall. So it makes sense to check other things first when troubleshooting. Plus, chances are that the CPU is not the issue. So your best bet is to check all of the connections for the Big Four first. Included in that, check the CPU fan. Check that connection for the CPU fan. Some systems won't boot if the CPU fan is not connected. Then check the CPU power connections, that 8-pin power connection, or 4-pin on older systems and minor systems. Check that on the motherboard. Check the main power, the 24-pin on the motherboard. And also whether or not the RAM sticks and the video card are seated properly. And check for dust and dirt in those slots. Those dust bunnies can be troublesome, especially if they make it into any of the slots. You'd be surprised how many times these things are the actual causes for why a system won't boot. You really want to leave taking apart the CPU till last. And, you know, it could be that the computer was jostled or moved to another location. It could be due to card creep. Maybe the video card or the RAM module kind of creeped out of the slot a little bit due to thermal expansion and contraction. It could be user error during installation, or perhaps poor manufacturing, though that is rare. Maybe some components don't go well together. Maybe the video card kind of gets pulled up over here because it doesn't connect well in the case. Whatever the reason, it's common for a technician to have to disconnect and reconnect components in the PC. So going beyond that, the CPU fan might be plugged in, but the fan might have failed or is failing intermittently. Replacement of the fan might be necessary. And while you're troubleshooting the CPU, you can also check if the RAM is really compatible with the motherboard. Then, if it is absolutely necessary, check the heatsink and check if it's installed properly and that there is thermal compound, and if the CPU is flush in the socket. Now, when doing this, if you ever have to remove the heatsink, you have to be sure to reapply thermal compound whenever reattaching the heatsink or new heatsink. Okay, so that's the big four aside from power. Now, in the objectives, the video is kind of considered a different objective bullet. That's okay, though. You kind of have to look at all this stuff together when you're troubleshooting. Now, sometimes the CPU is actually defective, and more on this picture in just a little bit. A defective CPU is not common for the typical computer, but it can become a bit more common for systems with heavily used CPUs, and especially overclocked CPUs. Here are some of the possible symptoms of a failing CPU. First, unexplained crashes during boot up or during use. Now, that could be a virus as well, but that's more the software side of things. Also, the computer locks after only a short period of use. You might also encounter unexpected shutdowns. And the voltage is near, at, or above the top end of the allowable range. Watch that voltage. And of course, another symptom is that the system simply won't boot. But that could be caused by a variety of things in the computer, not just the CPU. Sometimes these things can be attributed to a faulty power supply unit or a bad power rail, like a bad 8-pin CPU power rail. If you've ruled out power as being an issue, at this point it becomes a matter of trying a CPU reinstall. But again, before that, if possible, consider swapping components like the RAM and the video card, perhaps the motherboard. It depends. Depends on where your troubleshooting leads you. And I found this figure and I wanted to share it with you. I don't suggest you use metal tweezers in a PC ever. Instead, use plastic. Also, the operation this person is trying to perform here is difficult and not recommended. When you're working in the field, generally, we're going to swap out the CPU or the motherboard with a new one. We're not going to do any type of repair like this. So for the A+, these things are really considered field replaceable units, or FRUs. When swapping out a CPU, you might see things similar to the images here. Let's take a look at each one. On the left, we have some burn marks on the lands on the bottom of the CPU. So this is an LGA, it's an Intel-based CPU, and we have some burn marks here. So it looks like it overheated, probably an overclocked CPU, and the voltage just got to it over time. Not only does that damage the CPU, it usually damages the socket. And in some cases, you can change out a socket, but most of the time that means you have to get rid of the motherboard as well. Here we have another one. We've got some damage here and here. It appears that the thermal compound failed. It could be that not enough was applied. It looks like there's a lot here, but it could be that the heatsink was pressed down too hard onto the CPU, and it spread out the thermal compound so much that there was actually gaps where it wasn't covering. So you have to be careful with that. You don't want to press down the heatsink too hard when you install it. And here we have some burn marks on the cap of a CPU, and it looks like no thermal compound was installed at all. You know, in some cases you might have another cap over it, but here, you know, these burn marks occurred either way, so got to be careful with that. Make sure you install thermal compound and check for actual physical damage on a CPU. Let's do a quiz question. You're troubleshooting a CPU and have already cut power, disconnected the power cable, opened the case, and put on your anti-static strap. What should you do next? Take a look at the possible answers. I'll give you a moment to pause the video, and I'll come back in a couple seconds with the answer. And the best answer is B, check connections first. Always check connections first, because quite often those are the culprit. You know, it could be the CPU power connection, it could be the CPU fan connection, it could be that the video card's not connected right, it could be the main power. There's so many connections in there that could be loose or weren't installed properly in the first place. If you disconnected the power cable and opened the case, you're not going to be able to get into the BIOS. Removing the CPU is really the last thing you want to do. And testing the motherboard with a multimeter, you can if you want to test individual wires, but it's better to just test the power supply power connections, like the 24 pin to the motherboard, with a power supply tester, like the one we showed before. So check connections. Always check those connections first. It can very often be the answer to your woes. And another quiz question, what is a possible symptom of a failing CPU? And select the best answer from the list. I'll give you a couple seconds to pause the video. And the best answer is A. The CPU is beyond the recommended voltage range. If the CPU is running beyond the recommended voltage range for extended periods of time, it could be a sign of a failing CPU. It could be a sign of an overclocked computer, which could cause failure later. If the computer won't boot at all, another problem might have occurred, or the CPU might have already failed. Low case temperatures are a good thing, as long as they're not freezing. But low case temperatures is what we want. And spyware is unrelated in this case, but it could mimic some of the symptoms of a failing CPU, and you have to learn how to differentiate between the hardware and the software, which we talk more about as we go through these videos. So remember your 6-step troubleshooting process for CPUs. And let's do a little quick CPU analysis with HW Monitor. And so here's a HW Monitor. It's a free program that you can download as of the recording of this video. And you can take a look at all of, if your system is able to monitor these things, and if you have the BIOS or UEFI set up to do so, then programs like this can automatically view that information. So you could look at things like the voltage, various voltages of the system, like the CPU core. That's a very important one. And then your temperatures. The internal temperature of the system, the internal temperature of the CPU, how fast the fans are moving, and lots and lots of other stuff. You can look at the core temperatures for each core of the CPU. Here we have 6, and the package in general. This is one that I usually go to first. Utilization of each of the cores. If one is being utilized more than others, it could be a sign of something. So you want to watch for that. The speed at which they're running. I'm running real heavy because I'm doing a lot on this computer right now. And you can check all kinds of other stuff too, like your hard drives, your video card, which is commonly a hot one. M.2 drives are commonly very hot, so watch for that. But you can definitely check the CPU voltage and the frequency and the utilization, and of course the heat, the temperature. So take a look at that program. There's lots of other analysis and benchmarking programs out there that you might find interesting. Just do a quick search and you'll find all kinds of good stuff on the net. So there's a little bit of CPU troubleshooting and analysis. Let's move over to the RAM side. You know what the 3 biggest issues are when it comes to DRAM? Dust, incompatibility, and heat. In other words, dirty RAM, user error, and overclocking. which some might argue is also user error. Other than that, RAM should rarely fail. Now, the image on the left here is a travesty. There's a whole colony of dust bunnies in there. The image on the right, however, clean as can be. So, this kind of thing could cause some connectivity problems between the RAM and the motherboard, which could cause intermittent problems, programs failing, the operating system won't boot, system just automatically restarts, all kinds of stuff. So especially in dirty environments like warehouses and computers that are in outdoor areas, you want to definitely check for this. So what you want to do is you want to get rid of these dust bunnies. You could do that by blowing them out with compressed air. You can use just a basic can of compressed air. I have one that plugs in so it can constantly send out compressed air. That's a renewable type of thing, so it's a little bit better than buying the cans constantly if you do this often. And you could also use a computer vacuum. So the computer vacuum you have to be really careful with. You don't want to touch any of the components in here, and you want to make sure the nozzle is plastic, but you got to be real careful with that. You may want to blow out some of this stuff and vacuum out the rest, use both at the same time. And they make some computer devices, special computer vacuums that also act as blowers. So be very careful with this, though. You don't want to touch any of the components. You don't want to generate electrostatic discharge. If you do this outside, you want to make sure the motherboard is inside the case. You don't want to be just walking around with the motherboard, of course. And also any fans that might be there, you want to make sure you put some type of stopper in the fan so that it doesn't move. If you're using a blower and the fan starts to move, that could actually generate electricity. It could cause a charge. It could cause a discharge, some ESD, so be careful with that. But then you want to clean the RAM modules, the connectors, and you can use contact cleaner. I have Deoxit that I use, and also Stabilent 22. So clean those and make sure everything's all nice and clean, and you'd be surprised that it'll usually fix a lot of problems. But overclocking can be quite detrimental to RAM as well. Here we have the AI tweaker screen in the BIOS. It's ASUS BIOS. Let's zoom in on the memory section. And here, this actual RAM that we're using is 2133 megahertz RAM. That's considered the max that it should go. But you can see here it's set to 2400, so it's been overclocked. And, normally this is supposed to run around 1.1 volts, but due to the overclocking, the voltage is higher at 1.2 volts, which over time could damage the RAM, and it could cause the RAM to run hot. Now, we mentioned you could use the hardware monitor to check that kind of stuff, to check all these temperatures of everything that you have. So that's a possibility. And check that voltage as well to see if it's going too high. But in this case, we'd most likely want to take the clock down. And we do that here in this setting. And we'd want to take that down to the regular 2133 megahertz. Don't forget the big 4 when troubleshooting the RAM. Check everything in the system, because it might not be the RAM that's the actual problem. Sometimes it's hard to tell, especially if there's nothing coming up on the display. And be sure to always try cleaning out the RAM slots and reseating the RAM first before taking extreme measures. Here's some symptoms you might see. Sometimes the computer will not boot, or it intermittently shuts down. So you have to watch for that. That could be an issue. It could be RAM-based. But again, it could be other hardware components as well. Sometimes the BIOS will indicate a memory error when you actually boot the system, and that should also be logged. So check those system logs, and if it does come up with a memory error, look at the code and take that code and view what that code means. Could be a 3-digit or 4-digit numeric code. Take a look in the motherboard manual to see what those codes actually mean. Some motherboards have a built-in post tester, so watch for those too. And I show that in another video. And memory errors could occur that are software-based, for example, blue screens of death, BSOD. We'll be talking about those more in the software section, but you have to be ready to troubleshoot those as well. So these are some of the symptoms that could possibly mean a RAM issue. But as I mentioned, quite often it's going to be that dirty RAM, those dust bunnies, the overclocking, or just some type of user error. So let's do a quiz question here. You're repairing a computer that has been used in a warehouse for several years. You suspect a problem with the memory module. What should you do first? And I'll give you a couple seconds to pause the video, come back with the answer. And the best answer is C, clean the RAM slot, just like we were just talking about. Because the computer is being used in a warehouse, right? It's being used in a warehouse, which is often a fairly dirty environment because of boxes and pallets and who knows what else. Because of that, you should clean the RAM slot and the memory module. More likely, you'll use a blower and or vacuum for the slot, and you clean the actual memory module. And then maybe insert the RAM, take it back out, and clean it again, and insert it a second time. So consider using the compressed air, the computer vacuum, or the proper spray, like Stabilant 22 you could use also, and Deoxit, and so on. Clean out all of the dust bunnies within the entire computer. And then also you could consider using MemTest 86, which I think is now part of Passmark, or another memory diagnostic tool, perhaps the one built into Windows, the memory checker. So there's a little quiz question for you, and that's about it for this video on troubleshooting CPUs and RAM.